Hi there. This is a realistic DevOps interview simulation focused on networking and DNS failures in real production environments. These are the kinds of questions that test how you think when traffic doesn't flow the way it should, and users are impacted in ways that aren't always obvious. Before listening to each answer, pause the video and respond out loud as if you were the candidate. That's how you build confidence and spot gaps in your thinking. If this format helps you and you want more full-length DevOps interview simulations like this, subscribe so you don't miss the next one. Let's start with a warm-up. Tell me about a time a networking or DNS issue caused a production incident. A strong answer would sound like this. We had an outage where users couldn't reach our API even though the service itself was healthy. After investigating, we realized a DNS record hadn't been updated after a recent infrastructure change. Traffic was still being sent to an old IP that no longer existed. We fixed the record and reduced the TTL to stabilize traffic, then followed up by improving our deployment checklist so DNS updates couldn't be missed again. Next question. How do you usually approach debugging network-related problems under pressure? A solid response would be, I try to break the problem down layer by layer. I start by confirming whether the issue is client-side, network level, or application level. I check basic connectivity first, then DNS resolution, then routing and firewall rules. I avoid jumping to conclusions and instead validate assumptions step by step, so I don't waste time chasing the wrong problem. Another one. Tell me about a time you had to work with another team to resolve a networking issue. A good answer might be, during an incident involving intermittent timeouts, it turned out the issue was related to firewall rules managed by a different team. I coordinated closely with them, shared concrete evidence like logs and packet behavior, and made sure we stayed aligned on changes. Clear communication and shared ownership helped resolve the issue faster than working in silos. Next question. How do you communicate networking issues to non-technical stakeholders during an outage? A strong response would be, I focus on impact and next steps rather than technical details. I explain what users are experiencing, what we're doing to fix it, and when they can expect updates. If needed, I translate networking concepts into simple terms so stakeholders understand the risk without being overwhelmed by jargon. One more warm-up. What's a common networking misconception you've seen cause problems? A solid answer would be, a common misconception is assuming that if a service is running, it must be reachable. In reality, DNS, routing, firewall rules, and load balancers all have to be correct. I've seen outages where the application was perfectly healthy but unreachable due to a small networking misconfiguration. Let's move into technical and scenario-based questions. Explain how DNS resolution works at a high level and how that understanding helps during outages. A strong answer would be, DNS resolution involves translating a domain name into an IP address by querying a series of DNS servers, often starting with a resolver and moving through authoritative servers. Understanding that chain helps during outages because failures can happen at different points. Sometimes the issue is cached data, sometimes it's an authoritative record, and sometimes it's a propagation delay. Knowing where resolution might break helps narrow down the problem faster. Next scenario. Users report they can't reach a service, but only from certain locations. How do you approach this? A solid response would be, location-specific issues often point to DNS caching, routing differences, or regional network problems. I'd compare DNS resolution results and IP routing paths from different regions. I'd also check whether traffic is being routed through different load balancers or network paths. Differences across regions usually provide clues about where the failure is occurring. Another question. What role do TTL values play in DNS, and how do they affect incident response? A strong answer would be, TTL values control how long DNS records are cached. During an incident, high TTLs can slow down recovery because clients keep using outdated records. That's why we plan TTLs ahead of changes. Lower TTLs give flexibility but increase query volume. It's a trade-off between responsiveness and stability. Next scenario. A service is reachable by IP address but not by host name. What does that tell you? A good explanation would be that strongly suggests a DNS issue rather than an application or network connectivity issue. The service itself is up, but name resolution is failing. I'd check DNS records, resolvers, and whether the host name is resolving to the correct IP. That insight helps avoid unnecessary debugging at the wrong layer. Another question: how do you reason about firewall rules or security groups when traffic is failing? A strong response would be, I verify the expected traffic flow first: source, destination, port, and protocol. Then I check firewall rules in both directions, because inbound and outbound rules can both block traffic. I also look for recent changes, because networking failures often align closely with configuration updates. Next scenario: an application experiences intermittent timeouts, but only under load. What networking factors do you consider? A solid answer would be, I consider connection limits, load balancer behavior, and NAT exhaustion. Under load, systems can hit limits that aren't obvious at low traffic levels. I'd also look at retransmissions, latency spikes, and whether connections are being dropped or queued. These issues often surface only when traffic increases. Another question: how do you distinguish between a DNS problem and a deeper network routing issue? A strong answer would be, I start by checking whether the host name resolves correctly and consistently. If DNS resolution works but traffic still fails, I move down the stack and check routing, firewalls, and load balancers. The key is isolating each layer and confirming it works before moving on, rather than assuming DNS is always the culprit. Let's keep going. You receive alerts that services are timing out, but DNS resolution looks correct and consistent. What's your next line of investigation? A strong answer would be, if DNS looks healthy, I shift focus to what happens after resolution. I check whether traffic is actually reaching the destination by looking at routing tables, load balancer health, and firewall rules. I also look at connection behavior, such as whether SYN packets are being sent but not acknowledged. Timeouts often happen when traffic is silently dropped somewhere along the path rather than explicitly rejected. Next scenario: a recent deployment introduced a new internal service, and shortly after, other services start failing intermittently. How do you reason about this from a networking perspective? A solid response would be, I'd suspect some shared networking component was impacted, like connection limits, NAT capacity, or shared load balancers. I'd look at whether the new service increased traffic volume or connection churn. Even if the new service is healthy, it might be exhausting shared resources and indirectly affecting other services. Understanding shared network dependencies is key here. Another question: how do you debug a situation where DNS works in one environment but fails in another? A strong answer would be, I compare the environments as closely as possible. I check which DNS resolvers are being used, whether search domains differ, and whether there are differences in caching behavior. I also look at network policies that might block DNS traffic itself. DNS failures across environments are often caused by subtle configuration differences rather than obvious outages. Next scenario: users report that requests sometimes succeed and sometimes fail, even from the same client. What networking causes do you consider? A thoughtful response would be, intermittent behavior often points to load balancing or partial failures. I consider whether traffic is being routed to multiple backends and whether some of those backends are unhealthy or misconfigured. I also think about DNS returning multiple IPs and whether all of them are reachable. The key is identifying whether failures correlate with specific paths or endpoints. Another question: how do you think about diagnosing network latency versus packet loss? A strong explanation would be, latency issues usually show up as consistently slow responses, while packet loss often causes retries, timeouts, and erratic behavior. I look at round-trip times, retransmissions, and error rates together. Packet loss can be especially tricky because it doesn't always appear as a clear error, but it can severely impact performance under load. Next scenario: a cloud-based service works fine internally but fails for external users. How do you approach this? A solid answer would be, I consider differences between internal and external traffic paths. Internally, traffic may bypass certain firewalls, NAT gateways, or edge load balancers. For external users, I check ingress rules, public DNS records, TLS termination, and edge routing. Problems that affect only external users often live at the boundaries of the system. Another question: how do you reason about DNS caching when troubleshooting user-reported issues? A strong response would be, I assume different users may see different behavior depending on what's cached. I ask whether failures are tied to specific ISPs, regions, or clients. I also check TTL values and whether recent changes could still be propagating. DNS caching can make an issue look random when it's actually deterministic based on cache state. Next scenario. You suspect NAT exhaustion is causing intermittent connectivity failures. What signs do you look for? A good answer would be, I look for spikes in connection counts, increased latency, and failures that correlate with traffic volume. NAT exhaustion often shows up under load and disappears when traffic drops. I'd confirm how many connections are being created, how long they live, and whether connection reuse is happening as expected. Another question: how do you approach fixing a networking issue when you're not sure whether the root cause is DNS, routing, or application behavior? A strong answer would be, I isolate one layer at a time. I verify DNS resolution independently, then test basic connectivity using resolved IPs, and then look at application behavior. By validating each layer separately, I avoid making assumptions and reduce the chance of fixing the wrong thing. Final question for this section. When dealing with networking failures, how do you balance fast mitigation versus deep investigation? A mature answer would be, I focus first on restoring service in the safest way possible, even if it's a temporary workaround. Once users are stable, I invest time in understanding the root cause. Networking issues can be subtle, so trying to fully diagnose them while users are impacted can slow recovery. Separating mitigation from investigation helps manage both speed and accuracy. Let's move into the final section of this interview. These are the kinds of questions where there isn't a single correct answer. What matters most is how you reason through uncertainty and make decisions when the situation isn't clean. Here's the first scenario. Users across multiple regions are reporting intermittent failures. Some requests succeed, others time out. DNS looks healthy, load balancers report no errors, and back-end services appear up. You're on call. What do you do next? A strong answer would sound like this. I treat this as a partial or path-dependent failure rather than a full outage. I start by identifying patterns in the failures, such as whether they correlate with specific regions, ISPs, or request paths. I'd compare successful and failed requests to see what's different about their network routes. At the same time, I'd reduce risk by shifting traffic away from suspected paths if possible. My goal is to narrow the blast radius while gathering enough signal to identify what part of the network is behaving inconsistently. Next scenario. During an outage, someone suggests flushing DNS caches everywhere to fix the issue. You're not fully convinced. How do you respond? A thoughtful answer would be, I'd pause before taking that action and explain the trade-offs. Flushing DNS caches can help if stale records are the problem, but it can also cause a sudden spike in DNS queries and make things worse. I'd ask what evidence suggests caching is the root cause, and whether we can test the idea in a limited scope first. If we do decide to flush caches, I'd coordinate it carefully and communicate the risks clearly. Another pressure question. An executive joins the incident call and asks why the system looks healthy on dashboards while users are clearly impacted. How do you handle that conversation? A strong response would be, I acknowledge the gap without getting defensive. I explain that dashboards show specific metrics, but not always user experience or network path issues. I focus on what we know, what we're investigating, and what we're doing to reduce impact. I avoid deep technical explanations unless they ask for them, and I keep the conversation centered on outcomes and next steps rather than blame. Next scenario. You suspect the root cause is a subtle networking issue involving routing or packet loss, but you can't prove it yet. Meanwhile, pressure is building to roll back recent changes. What's your approach? A mature answer would be, I consider rollback as a mitigation option, not an admission of fault. If rolling back recent changes is low risk and could reduce impact, I'm open to it even if we're not certain it's the cause. At the same time, I continue investigating the networking hypothesis so we don't stop learning once things stabilize. The key is balancing speed, safety, and learning rather than getting stuck trying to be perfectly right. Final pressure question. You apply a temporary workaround that restores service, but it doesn't fully explain the root cause. How do you ensure this doesn't happen again? A strong answer would be, once users are stable, I shift into learning mode. I document what we observed, what the workaround addressed, and what remains unclear. I schedule time to reproduce the issue if possible and involve the right people to dig deeper. Temporary fixes are sometimes necessary, but I don't consider the incident closed until we understand the underlying failure and reduce the chance of recurrence. Now take a moment to reflect on this interview. Think about which questions felt straightforward and which ones made you uncomfortable or unsure. Networking and DNS failures are especially tricky because the symptoms don't always point clearly to the cause. What matters most is staying methodical, communicating clearly, and making safe decisions when information is incomplete. Let me know in the comments which question you found the hardest and what you would have done differently. If you want more full-length DevOps interview simulations like this, subscribe so you don't miss the next one.